kick off with the very generic open introduction to open science, and then I'll hand over to Alexandra afterwards to cover some of the terminology. So why are we talking about open science? And there are a lot of reasons and a lot of viewpoints on this. But we can start with some of the research that's been coming out on reproducibility. There's been a lot of research projects that have tried to replicate and reproduce research that has been published in peer-reviewed publications. And what has been found is that it's not always possible. In fact, it's very seldom possible to replicate studies across all disciplines. And open science is a way of making research more reproducible and trustworthy. Open science is also about giving access to knowledge with, as many of you will know, and specifically people who have tried to publish or people who have worked on literature reviews, there is a lot of knowledge that are hidden behind paywalls, which makes it very expensive to access. And that knowledge often has been paid for by public money. So the open science movement is also about making knowledge more accessible and open. It's also about stimulating innovation and collaboration. Again, the paywalled knowledge means that only certain people are able to collaborate and use the knowledge to innovate. But with open science, more information is becoming publicly available, which allows innovation and collaborations to take place. And of course, open science wouldn't be possible without all the technological advances that we've seen over the past 10 to 20 years. Because we have cloud and platforms, online platform systems, we can now get access to digitized data, collaboration systems, work across continents, collaborate remotely. So technology has been playing a huge role in the development of the open science movement. And then, of course, public demand for transparency. But there's also other reasons that we're talking about open science. One being funder requirements. So some of you who are at a stage in your career where you are applying for funding for your research, or where you are reporting to funders, will find that the funders are increasingly requiring open data, open access, and other open science principles to be applied in the research. Open science has also been playing a huge role in global challenges, for example, the pandemic, where COVID-19 sequences were shared widely and really played a big role in developing vaccines and making sure that the pandemic was understood better and contained eventually. And then ethical imperatives. There's also a big push for research cultural change, new ways of being recognized. So what you'll see in this workshop, we are not only going to focus on research articles, although we will give some pointers to how you can benefit within these traditional recognition systems from open science by publishing in open access journals. But there's also a whole lot of other work that's being done in the research landscape, which is not yet acknowledged for career growth, promotions, and visibility. So we are also going to look at that, and that really forms part of the open science movement. And then, as I said, lessons from crises like the COVID-19. There's a whole lot of things happening in terms of open science on the continent. We are part of high-level policy discussions. Recently, I was involved in a preparation for the African Union, where they are looking specifically at open science. South African government is working on an open science policy, which we saw a draft of in 2022, but they've been working on updating that draft and really thinking about how that can be implemented. There's a whole lot of open data platforms becoming available throughout the continent, and we'll point to some of them. There's an open hardware community that's part of the open science community. If you're not familiar with the open hardware community, you're welcome to Google, and we can share a link afterwards. GOSH, the global open source hardware community. There's also an African open source hardware community. There's a whole lot of grassroots initiatives where training is happening, mentorship is happening in terms of open science across the research lifecycle. Lots of national, regional, and international events taking place. In October, I know there's going to be an open science workshop in Zimbabwe at the Ubuntu Connect conference. You'll also see, if you are plugged into the communities, which we'll share with you later on, that there are other short workshops, webinars. Ubuntu Alliance is running an open science webinar series. RSSE Africa runs open science meetings related to research software. So a whole lot of events that people might not be aware of yet, but that is taking place. Also conferences, in person and hybrid and virtual. Lots of open infrastructure being developed, both in terms of computational infrastructure, like the Center for High Performance Computing in Cape Town, who develops the South African high performance computing infrastructure, and DERISA doing data intensive research infrastructure. There are loads of open access journals that are being published definitely in South Africa and elsewhere on the continent. And there's also slowly some funding becoming available for open science work in the continent. So globally, the open science movement is driven by the UNESCO Open Science Recommendations, which were published in 2021 and adopted by over 100 partner countries. So your country, South Africa, Tanzania, I can't remember who else, Mauritius. Our governments have all signed this recommendations and have committed to implementing and supporting open science in their research spaces. So there's some very, very interesting resources on the UNESCO Open Science website as well, feedback from the countries and plans, timelines, and so on, which is still under development. And later on, I have a slide which will show you just also to remember that open science is under development. And sometimes we get a little bit impatient with the implementation thereof and the requirements, the mandates that are being set. Sometimes it feels like it's a little bit with the chicken before the egg or the egg before the chicken. But there's a whole lot of things happening. And we hope that in this workshop, you'll also get access to where you can find out more about what is happening, both from a top-down and a bottom-up approach. So we've already said that open science should encourage collaboration. In due time, making research and making research and science and knowledge more accessible also means making it accessible in people's home languages. So making multilingual scientific outputs also something that people can be rewarded for and can benefit from. And finally, to involve society. And I think, again, that is something that Diplomic is doing really well, to reach out to schools and other parts of society, not just staying within the research community. So it's really important, and I think that's something that in open science conversations aren't always communicated well, to understand that according to the UNESCO Open Science Principles and Recommendations, there are 14 elements of open science. So when we talk about open science, often people have a bit of a defensive reaction in terms of they want me to share all my data, and I don't know what that means for me and my work, like the work that I've done. Or people might think that we have to publish in open access journals, but there's a whole lot of concerns around publishing in open access journals because of their impact factors or perceived quality. But with the following 4 slides, I'm going to show you how broad open science really is. And in the workbook, you can also see, some other ways of making contributions to the open science movement, but also benefiting from the open science movement and benefiting from open science practices in your career. So the first pillar of open science, according to the UNESCO recommendations, is open scientific knowledge. I'm going to flick through. Oops, I have to press this button. The second one is open science infrastructure, both virtual and physical. Then we have open engagement of societal actors, which refers to citizen and participatory science, volunteering, crowdsourcing, and crowdfunding. And finally, open dialogue with other knowledge systems. So these 14 elements and these 4 pillars are really what makes up open science. And if I go back to open scientific knowledge, you can see that it includes publications, data, open educational resources, which this course is an example of, open source software and source code. So for those of you in the room who write code and develop workflows, that is, if you do it right, you can publish it as open source software, open source code, put the right license on it, and we'll talk about licenses a little bit later, and also show how you are contributing and benefiting from the open science movement. And then open hardware, which I spoke about a little bit earlier. Now, again, what we're trying to do with this workshop is to give you enough knowledge and context to help you shape the open science movement. We, as Africans, can't just adopt open science as it is being brought to you by more established or different or research environments with different contexts. We really have to understand open science so that we can shape it to be something that works for us and that benefits our communities and our researchers. But if you don't understand the context of open science, contributing to it and helping to shape it becomes really difficult. So I wanted to show this slide just to give you an idea of the different ways that different lenses that open science can be looked at. So some people might look at it as access to knowledge is unequally distributed, and that's why we need open science. We can also look at it from a pragmatic point of view to say that knowledge creation will be more efficient if scientists collaborate. So that's very, very much open science in academia. Then infrastructure, that's what I'm really passionate about, is making research infrastructure more accessible and more open so that everyone can benefit from the investments in research infrastructure. Looking at it through the public lens is really making open science accessible to the public. And then the last one is from a measurement point of view, and that refers back to the change in research culture and looking at how can we change the way that research and research outputs are being measured and rewarded as well. So none of these lenses are right or wrong. It's just the different ways that you can come to open science. And it really helps to understand if you are in a conversation with someone about open science, or if you attend a workshop, or if you try and implement open science, that there are these different lenses. And then I think the other thing from an open science practitioner, from my own experience, open science is a bit of a journey. It's not you do 1, then 2, then 3, then 4, and then you get the gold sticker. It's a learning curve, and because there is a lot of best practices that are under development, the best way to get involved in open science is to try something that for you is maybe low risk or not a lot of work. Implement it in your own work, see how it works, see what the benefits are to you and the broader community, and then take the next step. And sometimes you'll go, you might start with publishing in an open access journal, and then you might realize that, oh, I also actually have open educational resources, which I just never perceived to be open educational resources. But I have these slides, and if I put an open license on it, this becomes contribution to the open science movement as well. So you might move back and forth between the different pillars and the different elements of open science as well. Don't get frustrated with yourself or impatient with yourself or others who are walking the open science journey, because it is only 4 years old, really. The UNESCO recommendations are only 4 years old. Although people have been working in the open science space, but specifically open access publications, for more than 20 years. So that was a very, very, very quick introduction to almost the history of open science and the scope of open science. What questions do you have?